Hello, hello, my favorite CopperCube people. So, um, no one expected, but we're actually doing the second part of our tutorial regarding MMO game in CopperCube with CopperCube. And yeah, today we're proceeding with the stuff which we made last time. And as you probably know, last time we made our character move and we actually getting this data from the server and the movement looks really janky. And so this is something that we're going to fix today. We'll not be doing anything with the server part, I believe. We are only be updating the front end. So first of all, what we are going to be doing is pretty basic. We are going to be using linear interpolation to calculate player position at given moment in time. So what is linear interpolation? Imagine you have your, let's just do it maybe that way. So you have your x-axis, the character is moving, and you have your time. So basically, every time your character some time passes. For example, here I have like 100 milliseconds, 200, 300. Our player move to a certain distance. Let's say it will be like 20, 10, 20, and 30, and so on. And basically for our player, the graph, the diagram, how it moves, it will look like that. Basically, it's a linear diagram. So at 10, I mean, okay, maybe it's like let's just something like that, so it's easier to calculate. Let me just redo the line. So basically, it will be like that, then like that, and like that. So for example, at 100 millisecond, it will be in position 10. At 200 millisecond, it will be at position 20, and so on for forever until it runs. Basically, how do we calculate at which position our character was at 150? We just do it like that, and then on this axis, we know that it's 15. And basically, this is a linear interpolation. This is what we're doing. And probably it will be easier to understand from the code, so I don't have that much time today, and let's just skip to coding. And basically why we also choosing 100 milliseconds, it's because we get the response from our server every 100 milliseconds. We're getting data from it. So let's start by modifying our get data script. In order to be able to calculate some value using linear interpolation, we need to know at least two values between which we are going to be interpolating. So we need a way to store them. For that, I'm going to be using a simple array. So I'm going to create a states array, and instead of applying player data here in our request, in our get data function, I'm gonna create a new state. I'm gonna push it as a state. So data will be JSON parse and then data. And also, since I need a time in order to interpolate properly, I am gonna introduce received at property, which will be just date, that data transfer date now, which will give me a time in milliseconds. And in CopperCube, you can't have this, how it's called, comma here. And we don't need that now, so we don't need this completely, and this stuff should be moved to our controller function, and we'll just put it right here. So first of all, we also need a couple of new variations, which will be like next and previous. Next state, so if we follow this diagram, it will be this one, it will be the target state, and the previous state is the start state. And so we will be interpolating between them. First of all, we need to identify them. So for that, I will just go through the whole states array, like states length, I plus plus, and each time I pick a new element, I'm gonna assign it to next. So it will be states I. And in case, okay, we also need rendering time. Oops, sorry for that. Rendering time, which will be our cutting time minus 100 milliseconds, something like that. And in case our next state received at is great, I'll just copy it to make sure I typed it the same in both cases. Is greater that, right? It should be greater that our rendering time. In this case, we will break, and we will also assign our previous state as our state I minus 1. So in case we have both next and previous state, which are basically conditioned for our interpolation, we can actually interpolate. In order to do so, we also need to calculate our interpolation coefficient. I'm not sure, like interpolation state, which could be either 0 if we're in starting position or 1 if we're in like final position in the end. So for example, for this position here, it will be 0.5. We will calculate it as our rendering time minus previous, oops, it will be k equals rendering time minus previous received at, and we will divide value by our next received at minus previous received at. Yeah, so the very next thing, obviously CopperCube doesn't have this nice interpolation function, so I'm just going to copy it from another solution. Here we are. It receives three, so the function itself receives three properties, not properties, arguments. It will be initial value, an end value, and also the coefficiency. I'm not sure what the word is, but basically the value from 0 to 1, which tells us how far we are in the process. I also have the similar function for Euler because it has some 4 degrees, because it has some specifics. Like for example, if you're interpolating from, let's say 10 to 350, it's faster to interpolate to the left. So it's faster to go from like 10 to 0 and then to 350 than to go like, the whole right loop. So I also have a little clamp function here, but we will use it later. So for now, let's also modify our properties here. So for x, our new x value will be lerp, and then we will have previous data x, when we will have next data x, and we will have our k here. For y, we will do the same. For y, which is actually z, it will be prev data x, next data, not x, y. And we will have k here. And for our rotation, we're not gonna be using anything right now. We can do it later. Let's just see if it works right now. So I'll just do like next data, next data. All right. And let's check if it works. It doesn't because state is not defined. Controller 64, 65. Let's just see what happened here. 64. So next received states. What? Next received it. State. It should be states. All right, of course. It's just a typo. Let's see if it works now. No, next is undefined at controller 64. What? Next is okay. It just states I. What have I done? Oh my God, it's so stupid. What am I doing? What are you doing? So now it should work. Okay, so now as you can see, we are moving much smoother than it was before. And also, strangely enough, FPS is fine. So this was sort of an easy fix, I guess. Not that easy, but I mean, at least it works. The very, so not very, the next thing that I plan to do, and I think I still have time to do, is to update the camera movement. So currently our camera is just following our player from behind. I want it to be, I want it to, um, I want the possibility for it to rotate um, around the player. And for that, we'll create a new sphere, 0, 0, and this will be our so-called cam. It will be like player cam target, and we will put it on the player. So our camera, and also we'll change position to 0, 0, 0, and disable collision and disable occlude slide. And we will change our object to follow to this player cam target. So if you run the game right now, you will see that our camera is not rotating anymore, but we are going to fix it in a moment. So what we do need to do here, first of all, I want the camera to not rotate all the time, but instead it will only rotate in case the right mouse button is pressed. So for that, I'm gonna introduce another property, which I will call is right mouse button pressed, and by default it will be false. And here in my on mouse event listener, I will add another event, which will be event, I believe it's 5. Let's just check it really quick. So yes, it's event 5 for right mouse down. And if right mouse down, we will say that is right mouse button pressed will be true. And if event is actually 4, in that case, we will say that is right mouse pressed will be false. So I also, in case I'm pressing right mouse button, I also want our cursor to be fixed at center of the screen. So the very first thing I need to do is to just move cursor in the middle of the screen. So I'll just do set mouse position to get screen height by 2 divided by 2, and this is also actually function, and screen width divided, okay, so suppose it, I think it will be screen width divided by 2 and then screen height divided by 2. So that way, if I press the right mouse button, the cursor should move to the center. This is exactly what is happening. And here I will add, after that, maybe I will add additional checks. So if this right mouse button pressed, in that case, I'm going to rotate the player cam target node. In order to rotate it, as usually, I need to reference it first. So we will say this cam target node will be gets in node from name and put our node name here. So every frame I will calculate how like the mouse movement on X and Y axis. So for that, what I'm going to do, I'm going to, first of all, I'm going to find half width of the screen. It will be the screen height, screen width, I mean, and with the th, and I also do half height, it will be similar. And then I'm going to calculate the difference on which mouse was moved from the previous frame. So I will just do height. Oh no, CCB mouse position X minus half height, and I will do the same for Y. So it will be position Y minus. What is it's half width here? I'm not sure. Like why I'm messing words that massively today. I just don't know. And after that, we also need to sort of nullify our cursor position. So we will just say that we going to set our cursor, not the cursor, set mouse position to half height and half width. The opposite thing. So it will be half width and half height, something like that. And now, so now we have basically we have a mouse input here. Now we need to rotate our node, camera target node. So first of all, let's just get its rotation. Cam target rot will be gets in node node property. This cam target node rotation. And why am I doing that? And now we need to modify the rotation. So basically our dx rotation multiplied by delta will affect the rotation on y. So we will just do y plus equals delta, and I think we also need to multiply it by some value, but we will figure it out. And also our di will affect x, so it's sort of opposite. And we're gonna set this property back now. So with our cam target node rotation will become our cam target node, our cam target road. So like that. I guess it's like that. Let's just see. So now if I press right mouse button, I can rotate and something is messed up. So I need to multiply it by some value. Let's just say like 0.1 or something like that. So it's a little bit smoother. Okay, so now I can rotate, but it's still pretty fast. So let's just do it even slower. Like, oops, like that. I don't know. We can figure out the values later, and it doesn't seem to work right. Or does it? Oh, okay. And also I need to check if like my mouse has correct sensitivity. Yes, it does. So now, okay, so now something is really slow here, no, it's not slow actually. So now I can just rotate it as I expect, but for some reason my mouse cursor is not set to the position that I expect. It's set to the right corner. And I know exactly why this has happened, because I forgot to divide the screen resolution by 2. So now if I move it, it moves pretty okay, and I also can see the sky is messed up, but overall it's fine. And so if I move somewhere, now my character moves okay. It's even a little bit slow. Let's just do maybe 0.2 or something like that. 0.2 will be too fast, right? My favorite part about it. No, like 0.2 works okay. So it like how player currently, I'm sort of satisfied, but not quite, because player rotates a little bit faster to my taste. Let's just use our Euler linear interpolation function to make rotation more smooth. So we will just add it here, and we will add the coefficient here, and we will also do the same for our previous data, like that. And that would be it, I guess. So now, okay, now it's much smoother, I think. We can actually even don't do it with the coefficient. We can do it like 0.12 or something like that. So with the constant value, it even it looks really weird, to be honest. Why? Because I haven't put it in the correct place? Nope. I don't know why it looks so weird. Let's just do it with K. Not sure. It should have worked properly, but whatever. So now if you just check it again, yeah, it sort of looks okay. So it takes 100 milliseconds for him to turn. And I think like the picture is still a little bit so it's a little bit janky, so we will just do the very last thing which we can. And basically we will just move this player camera target away from player, and we will do a linear interpolation, as you already guessed, for camera target position. So we will just do cam target pose equals gets in node property with cam target node position. Oops, not the correct position, so it will be just position. And do we already have a player position? No, we don't. So let's just do player pose equals basically the same, but we will have player node here. And we're gonna set our target position x to be equal to cam target position x, then we will have player position x, and here we need to use some sort of like static data delta here, like 0.1 or something like that. It also won't. Okay, should it work? I think it should. And also we will do the same for our z position, so it will be z, and we will actually do the same for y position, just for maybe future compatibility. And also let's just move this like 0, 1 to call it smoothing or something like that, and put it here. And let's just use smoothing here also. And we need to apply our position back, sets in node property. Oop. Cam target position. Oop. No. This cam target node position, and also cam target position, right, like that. And let's see if it works actually. Oop, it doesn't, right? We're somewhere far away. And why is it so? We have it here, we have player position here. It should actually work. Camera target position, player position. That's pretty weird. I don't think I'm messing something up, but if we just remove this, will we have some sort of movement or something like that? Oh, okay, it's far away from us, yeah, but let's just stop the server really quick. Okay, so now it's not moving, which is expected, but this is pretty weird. Oh, okay, maybe let's just do it like that. It's sort of weird because it doesn't work as I expect today for some reason. I'm just not sure what is happening. I'm pretty much sure it should work. Well, at least by looking at it. So I have like position X, position X, position Y, and I also have cam target position Z and player position Z. All right, let's just check it again. Oh, now it works. I have no idea. So it's like the smoothing values. Okay, I guess it's just because I was I'm not sure why. Okay, to be honest, I'll just be honest with you. I don't know why. Let's just say it to 0.2, and see if it works again, because to me it seems like it should be working as it was. And it doesn't feel like it fixes a lot, to be honest, but anyway, it's something that I think will look better in future, I guess, I hope. So, yeah, also we have an issue with the code, don't, which I haven't thought of. If we just print out our state length, we will see that amount of states is increasing all the time, which is not good because we have to store this data somewhere, right? So for that reason, what we're gonna do is we're gonna remove the states which we don't use anymore. And for that, I also need to have this I here because I need to access it from inside the if statement. So what we're gonna do, we're gonna just say that states I equals states slice, slice I minus one, I guess. And let's just check it again. I removed print statement? Yes, I think I did. Print states length. Let's just go again. And so now we constantly having two states, which I feel like works much better. Okay, so now we have our movement, which is a little bit janky, but not as janky as it was before, to be honest. I'm not quite sure why is it still sort of like moves like that. But I mean, anyway, we will figure out it in the future. If it becomes unplayable or it looks too bad, we always can figure it out, right? So I think that was it for this particular episode. And the next one, I should be in a good shape because we're doing some really interesting stuff. And we are going to be actually adding multiple players. So our game will become a real multiplayer game. Yeah, so that's it for today. Have a nice day. See you.